Hello friends, welcome to Maths Nerd.
Today, I will show you some interesting multiplication tricks to boost your calculations. You can multiply any number by 11 using this trick. So, what's 43 into 11? That's 473, and you can do it quicker than me if you are well aware of this trick. So, it says that first count the number of digits in the number. So, if 43 has 2 digits and add 1 to it. And that many blanks you will require for writing the answer, and that's the step 1. And then in the first blank write the first digit of the number, in the last blank write the last digit of the number. And then starting from the right hand side, you need to from each blank you need to find the sum of the last two digits. And then for example, for this blank, we'll write the sum of 4 and 3, that is 7. So it's 473. Now let's see a 3-digit problem to understand how to do this in 3 digits. So 531 has 3 digits. We'll make 4 blanks. Then we'll write 5 in the first blank, 1 in the second, last. And then for the remaining blanks, in the last remaining blank, we'll write the sum of the last 2 digits, and in the second from the last remaining blank, that is this blank, we'll write the sum of these 2 digits. So it is 5841, because 5 plus 3 is 8 and 3 plus 1 is 4. Now let's see another problem where the concept of carry is involved. 495 into 11. So what's different in it? Let's see. We need 4 blanks because the number is 3 digit. We'll write 4 and 5 in the first and last places respectively. And then in this blank we need the sum of 4 and 9, and in this blank we need the sum of 9 and 5. But both of these are 2 digit. So how to handle these? So we our answer would look something like this: 4, 9 plus 4, 5 plus 9 and 5. But we need only 4 digits. So what to do? We can write this 5 plus 9 as 14, and 1 goes as a carry to 9 plus 4. That is the next digit on the left hand side of that digit. So this digit will be just 4, and similarly this digit will also be 3 just, and the 1 will go to the last digit here, like this. So we'll add 3 plus 1, 4 for the hundredths digit, and 4 plus 1, 5 for the thousandths digit, to get our answer 5445. And this is true, and you can verify it by calculator. Now let's see the epic problem, 5 digits. So if there are 5 digits, we will need 6 blanks. So here they are. And then in the first blank we'll write 5, in the last blank we'll write 9, like this. Then in this blank we will write the sum of these two, in this blank we'll write the sum of these two, in this blank we'll write the sum of these two, and in this blank we'll write the sum of these two. So 5 plus 2 is 7, 2 plus 7 is 9, 7 plus 2 is 9, and 2 plus 9 is, well, yes, 11. So it looks something like this. So 2 plus 9, 11. So this will be a 1, with the 1 going as a carry to this digit. And 7 plus 2 is 9, 2 plus 7 is 9, and 5 plus 2 is 7. And then you can notice that 9 plus 1 is 10. So we need to give carry to this, and this will become 0. But since it is 9, this will also become 0, and the carry will be forwarded to this. So our final answer will look like this: 5,80,019. Now let's see the proof of this trick to show you that this trick is valid in all cases. So for the proof, we will uh, uh, we'll first start with two digit numbers multiplied by 11. So let our number be 10a plus b, because all two digit numbers can be represented in this form, where a is the tens digit and b is the units digit. For example, 51 will be 10 times 51, where a is 5 and b is 1. So 10 times 5 is 50 and b and plus 1 is 51. So now let's multiply it by 11. So 11 times 10a plus b will be our answer. And 11 is 10 plus 1, as we all know. So it will look like this. And then we can open the brackets. So 10 times 10a plus 10 times b plus 10 times a plus b. So now we'll have 100a plus 10 times a plus b, and we have factorized these two terms into this and plus b. So in the hundreds digit we will have a, in the tens digit we will have the sum of a and b, and in the ones digit we will have b. And that was what we exactly did in the case of 43. Now let's see the proof for three digit numbers. So 3-digit numbers can be represented in the form of 100a plus 10b plus c, like 121 can be represented as, where a is 1, b is 2 and c is 1. 100 into 1 is 1 plus 10 into 2 is 20 plus 1 into 1 is 1. So 121. Now let's see what happens when we multiply it by 11. So 11 can again be represented in the form of 10 plus 1, and we'll again open the brackets. 10 times 100a plus 10 times 10b plus 10c plus 10 plus 100a plus 10b plus c. And again we'll simplify it further and then factorize. 1000a plus 100b from here, 10c, 100a as it is, and 10b plus c as it is. So now we'll observe which variables have what numerical coefficients. 1000a as it is, 100 is common in a and b, so we'll factorize by grouping the common factors, and 10 is common in b and c, so we'll factorize them too, and c is alone. So in the thousands place we have a, in the hundreds place we have a plus b, in the tens place we have b plus c, and in the ones place we have c. And this proves that we what all we did was correct algebraically, and this even accounts for the carry. For example, if a plus b is greater than 10, then say it is 11, then it will be 11 hundreds, and since we have to accommodate in the hundreds place, we'll write here 1 and the carry will go here, and which is correct because 11 hundreds is 1000s and 100s. Now, let's see how to multiply numbers between 10 and 20. Now, after this part of the video, you can multiply any numbers between 10 and 20. So let's say 12 and 13. Well, that's 156. And you can solve faster than me if you memorize this trick easily. So let's see. First you need 3 blanks, because since the numbers are less than 20 and greater than 10, they will always be 3 digits. First blank should be always 1 for the beginning step, and then second blank will be the sum of the units digits of both the numbers, that is 2 and 3, so that's 5, and the last blank will be the product of the units digit of both the numbers, so that's 3 into 2, that's 6. So 156 is the answer. Now let's see 12 into 14. So 3 blanks. First blank is 1, second blank 2 plus 4, so that's 6, third blank 2 into 4, that's 8. So 168 is the answer. Now let's see 19 into 15, and here the concept of carry is involved, which we will deal in the same way. First 3 blanks, second 1 in the first blank. In the next step we will have to write 9 plus 5 in the second blank. So that's 14, but we will write 4 and 1 will go to the carry for the hundredths digit. And then in the third blank, 9 into 5, 45, and 4 will be the carry, 5 will be the units place. So 4 plus 4 is 8, 1 plus 1 is 2, so 285. And that's our answer. Now let's see the proof of this trick. So let's say that our numbers are 10 plus a and 10 plus b, because since both the numbers have the tens place as 10, so on opening the brackets we will have 10 times 10 plus 10 times b plus 10 times a plus ab. So that's 100 plus taking 10 common in a plus b and plus ab. So 100 can be represented as 100 times 1 plus 10 times a plus b plus ab. So in the hundreds place we have 1, in the tens place we have the sum of a and b, that is the units digit, and in the units place we have the product of a and b, that is the units place. So this is proved. The best trick to multiply any two numbers with difference 2. Let's see how to multiply a pair of numbers which have a difference 2. So let's see what's the product of 24 into 26. That's 624. So let's see how I did it. For that I did the square of the number between these two numbers, that is the number between 24 and 26 is 25, and subtracted 1 from it. So 25 squared is 625 minus 1 624. So you can use this trick only when you know the square of the number between them, or else it will not be useful for you. Now let's see what is 39 into 41. So the number between 39 and 41 is 40. So 40 squared minus 1. So that is 1600 minus 1. So that is 1599. And that is the answer. Now let's see the proof of this trick. So for proof, let the middle number, that is the number between the two numbers which have difference 2, be a. So the greater number will be a plus 1 and the lesser number will be a minus 1. And their product will be a plus 1 into a minus 1. But we know that a plus b into a minus b is equal to a squared minus b squared, and that is an identity. So a plus 1 into a minus 1 will be a squared minus 1 squared, and 1 squared is 1, so a squared minus 1. And that's what we did.
Feel free to ask your doubts in the comments. Thank you for watching this video. Please like and share this video and don't forget to subscribe my channel for more videos.